Hello, everyone. Welcome back to week 1, day 2 of learning the basics of C++. Today, we will mainly go over variables, if statements, modular division, and so much more. So we'll discuss variable declaration versus instantiation, if statements, which function as gates within programs. And this is really helpful because sometimes we only want to execute certain pieces of code if a condition is met. Okay, going back to last class, we talked a little bit about how math and C++ intertwine. So actually, there's a lot of math in C++. We have addition, subtraction, division, and multiplication, and that pretty much works the same as it does in normal math. You know, like 8 times 2 is 16 in computer science and also in math. And all of our mathematical operations, like the ones I just talked about, they follow PEMDAS. So there is this hierarchy. So everything in parentheses, exponents, multiple division, they all go first, and then addition, subtraction will be conducted later. So this is the order it will go in. And in C++, there is one thing to note, though, where if you try to do division with ints, remember ints are just numbers without any decimal places. So like these numbers right here. So if you try to do something like 9 divided by 6, in math, you'd have a decimal, you'd have 1.5. But in computer science, especially if you're using ints, inner divisions always discard fractions. So the 0.5 is not a part of the answer. But you might be wondering, what if you want to save the 0.5? Well, you can always use the double data type to do normal division with decimals. So we'll go over all those data types in a bit as well. And there's this new mathematical operation you probably haven't been exposed to yet, and it's called modular division. So in math, we always do division either by having the decimal place there or taking the remainder. And modular division is focusing on the latter. We're focusing on the remainder part of the answer you'll get. We want to get remainder 1 when we do modular division, and basically that will be our answer. So if we do 17 mod 2, our remainder, which is 1, is going to be the answer. Try not to think of it as a decimal sort of thing. Just try to do 17 divided by 2 in your head. If someone tells you what's 17 mod 2, just do 17 divided by 2 first, and you see, okay, so it's 8, but it's also remainder 1. So just have that remainder 1 stored in your head, and that is your final answer. So if you want to find the remainder and keep that as your answer, because sometimes in certain mathematical functions, you might need that. So that's when you do modular division. So another example is 16 mod 2. So we know in normal math, 16 divided by 2 is 8, and there's no remainder. So we can simply put 0. Same thing here, 12 mod 7. You'll just have the remainder left, which is 5, and you can keep that. But this last one is a special case. So you might be wondering, okay, this is if I try to do 3 divided by 12 here, I'll just probably get a decimal in real life. Well, when you're doing modular division, if your first number is less than your second number, that first number is your answer in modular division. And let's just say you have 12 mod 12. That would also be 0 because there is no remainder. So these are all a couple things to know as we get more into math, because throughout this bootcamp, we'll be using a lot of math in C++. Okay, now let's take a look at if statements. So we already talked about how if statements function as gates within programs where certain lines of code are run if a certain condition is met. Another important thing to note is that it's pretty much like English, where if a condition is met, then you do something. Like if I go to the store, I'll probably just go in the store and buy groceries or something. If I go in the grocery store, something like that. So there is a condition which is always in parentheses. And that gets executed if it's met. Like you can say in C++, we have conditions like if x is equal to 5, then print out, congratulations, you're 5 years old or something like that. So then you can do whatever code is there based on the type of problem you are solving. So in C++, this is how it's formatted, where everything enclosed within the brackets are your code that will be executed only if this above condition is true. And sometimes these brackets can have multiple different lines of codes, and sometimes they can even have other if statements. So you can practically have nested if statements where there are many if statements within each bracket of code. And remember, an important thing to note is that we already talked about lines in C++ ending with a semicolon, which still remains true for the code inside here. But the if and the condition does not require a semicolon. It's not really a complete sentence. It's if something, then you execute whatever is in here. So it's still like English in that manner. And whenever we compare anything in our condition, if we are using equality to compare if something's equal to each other, then we compare them with two equal signs, because one equal sign is actually an assignment, which we'll talk about some more, but it can either be true or false. And remember, if this is true, then the code gets executed. So this is a more common example of what we'll see. So if our two ints or whatever these variables were instantiated as, if these two values are equal to each other, then we would just print out same. That's it. That's basically a general overview of if statements. We'll get more into it in the next slide. So we already talked about if statements having multiple different if statements within them, which I know it sounds insane, but we'll do a demo shortly of how that looks. And hopefully that will also clear things up. And you can even have something called an else if statement to test for multiple different probabilities and outcomes you may have. And all of this, again, just works with the condition, and it's checking whether or not that condition is met. So you have an expression you're just trying to test. And if it is false, you don't do anything. You just go back, exit that if statement, and you do not really execute the code in the brackets. Remember, the body of the if is everything in the bracket. So if it's true, you execute the code. If not, you just do the statement below the if bracket. So this is a cool example to look at. We have our library there that helps us with cout and cin. We have using namespace std. And we have our main right here. This should look hopefully familiar. And then we have our int number, which is of a variable called number, which is of the int data type, which just stores a non-decimal number. So we have a cout statement saying enter an integer. And then we have cin actually taking our number user input. So if whatever our user inputted for the number is greater than 0, we execute the code here. If not, then we just go outside of this bracket. We do not even go through this. The compiler will skip everything in these brackets. So let's just say our number is 10, so it is greater than 0. Well, it is positive. This if statement basically checked whether it's positive or not. It did that, so that's why, and it prints out you entered a positive number with the number there, and then you have endl, which just moves everything all on one same line, and then the next line has to be different. Endl is like a new line. Now what we're going to do is we're going to take this code, modify it to have a couple more different statements. So we want to test for different probabilities. Right now, this code is pretty good. It just tells us that, hey, you entered a positive number, which is true. But what if you had a negative number there? What if our number was 0? Let's just try it out and see what would happen. What I will do is I will take a look at Okay, so I'm just going to really quickly comment this out and we'll take a look at this example that I made shortly. We'll just really quickly do this part. Okay, so we have int number entering an integer. So we have our if statement. And I'll just really quickly get rid of the comments since you guys know what it does. And it's always good to indent and have your brackets clean so you can see what's referring to what. And if you don't have brackets and if you have multiple different statements, only the first line will be executed. So if you have something like this, where you have 3 statements down below, the only thing that's going to be executed is this one line because you didn't have brackets. How is the compiler going to know that all of these are referring to that one if statement? That's why it's very important to have brackets and have clean code. So we talked about 2 different probabilities. So we have when your number is greater than 0, then we also talked about when your number is less than 0. But what about if our number is equal to 0? So let's go ahead and try all of these out. So rather than using 3 different if statements and just modifying the condition, we're going to do it a different way. So the one way you can do it is just changing this to be a less sign, changing this to be 2 equal signs to a test for equality. And then you can just simply change this. So you can do it this way, but it's not the most efficient way. What we'll do is we will actually use else if and else to test this. So what I'll really quickly do is I will show you guys an else if where our number is less than 0. And this is basically just another if statement. It has nothing to do with the one above. It's just if this is false, we go ahead and test this. And if this is false, we go right into the next one if there is any. And right now we just have an else statement here. An important thing to note is you can't have a condition next to an else statement because the else is almost like a catch-all. And this catch-all is just saying, okay, you went through all the different possibilities above. Now, if there's something random that does not fulfill any of these conditions, then execute whatever is in here. So this is if above conditions are not met. So we entered a positive number. That's why we have it greater than 0. We entered a negative number. Now what I'm going to do is just have this catch-all for anything else that happens. And this catch-all will primarily just be for 0. 0 is the only one that will fall into this category. Okay. So else, I just want to print out you entered a 0. And remember to comment. I can do /, but since this is a little bigger piece of code, I'll just do this, an asterisk and a slash. Okay, now let's go ahead and run this. Okay, so let's see real quickly, what are we missing here? Oh, it's important to keep it clean. We actually took out a bracket. Remember, our main always has to have a bracket there. So that's a good thing to catch. So we have each and every bracket coinciding with each and every condition, which is perfect. But remember, we can't forget that bracket that is the overarching brackets for the main. Okay, let's go ahead and enter an integer, and we'll try this different times. So I'm going to enter 10. Okay, great. We entered a positive integer. Now I'm going to run this again, and this time I'll add a negative integer there. I'll have a -6 there. Okay, we entered a negative integer. Perfect. So now I'm going to add a 0 there. Let's go ahead and test that out. Now this should fall within our catch-all category. Let's go ahead and try that. Perfect, we entered a 0. Everything worked as intended, but I'm going to show you guys another cool thing you can do. So if you wanted, you can also change this condition to be an else if number is equal to 0. And then you can go ahead and it'll still work as intended. It'll just save more time if you use an else, obviously, but if you wanted to use multiple else ifs, that's fine. But you can only have one if, you can only have one else. That is the important thing to note here. So a 0, yeah, it's still going to do the same thing. And it works just fine if you don't have an else. You can have multiple different else ifs, but it's important to have, again, one if, one else. Now that that's done, I want to show you guys something else to know about data types. So there's a reason why I wrote integer here, because we're only testing it with ints. So if we added like a decimal or something, that would technically be a double. So that's going to cause an error, right? What do you guys think? Let's see. Well, this is confusing, guys. I wonder why it just chopped off the decimal point. Well, if you remember correctly, in the PowerPoint, we talked about how an integer only takes in the integer part of our user input. So if we added more decimal points or 100 point, whatever that stuff is at the end, it's only going to take everything before the decimal point. It's only taking in an int. And that is an important thing to note here as well. Okay, so I think we are good with this example. I'll just really quickly comment this out. Okay, and now we will try another example using this. So I briefly mentioned that, you know, an int obviously has to take in an int, or else it'll only just take in whatever int parts are available there. So let's take a look at another example of where integer division happens and it cuts off the rest of the decimal places like we just saw here. Okay, so right here, we're just going to take an area of a rectangle. So let's go ahead and try that. So we have the double B, which stands for our base, double H, which stands for our height, double area, which stands for the overall area. And in math, you conduct this by just multiplying your base times your height. And that's pretty much what we're going to do here. And this is just the area of rectangle. And then we'll also try area of a triangle, or a right triangle. So for the rectangle part, it should be pretty straightforward. You're just taking in two values for the base and the height, and you are simply multiplying base and the height to get the area. So base times height, and again, you end with a semicolon, then you're just C-outing the area. So area is now being instantiated to have this value. So we are giving area the value of B times H. Let's go ahead and run this. So I'm going to add the number 7 there, the number 9 there, 63. Perfect. So now we know it works fine, but we just did this for ints. Remember, double has a lot more space than an int. Doubles can take in decimal values, larger numbers, while ints cannot take that in. So that's why it was able to just do an int multiplication. And now, if we just tried to do an int division later on, we'll also see that it should work. But we'll go ahead and take that in a second. The next thing I want to show you guys is to do a double multiplication because we haven't done that yet. So I'll just do 10.4 and then I'll do 10.7, 111.28. So that works perfectly as intended. You know, it's a double. We have a double base, a double height, and we're just multiplying them to get the double area. We're not doing anything too crazy here. But now what we're about to do is pretty crazy. So let's go ahead and take a look at what will happen if I just do half base times height. Okay, this is for our right triangle example. Just trying to get the area of our triangle now. Okay, let's go ahead and try it with the values 10 and 10. Okay, that is definitely not the right answer. Well, let's take a look at line 13 and debug and try to figure out what we're messing up on. So we have area is equal to half. Well, since half 1 divided by 2 is essentially 0 because it's an integer division, that's why it's probably multiplying 0 times base times height. And remember, it executes everything in the brackets first. So let's see. How can we fix this? Well, the easiest way to fix this is to simply change this so it becomes a decimal, and it will then conduct a double evaluation of this division problem. So since they're both doubles, we can easily divide them now. So let's go ahead and try to see if that fixes it. Perfect. Now we get the true answer. We get half times our base times height. So this is a really, really important thing to note. It catches people really quickly. So you really have to make sure that you aren't doing integer division by accident. And you have to double check that you're taking in the same values, that you're clean, that you're doing clean coding, which means it's indented nicely and all your brackets are there. And that's pretty much it for this short demo. Now let's go back and take a look at variables. Okay. Okay, so a variable is a named item. It can be X, it could be user input, and basically it just holds a value. We've already seen a ton of examples like that, but it's good to talk about it some more. And an assignment is where a variable is assigned with a value, like X is 35. Assignments can also be in the form of expressions. So you can have X is 355 plus 5 plus y. That expression is perfectly fine. Or you can do a simpler expression like y equals y plus 1. I know this looks really crazy at first and it may not make sense, but a good way to remember this is your new y value. This refers to your old y value. So if you see this statement and before your y was just simply 5, you can just do 5 plus 1 is your new y value. So which becomes 6. So new y is old y plus 1. So your y was 5 originally. That's there now. You add 1 there, and then it becomes 6. And note, 1 equal sign is for assignment, 2 equal sign are to test equality. And a really common thing you'll see in a ton of C++ programs is where people increment a value by 1. And that happens, and this is one way of doing this, where you have X equals X plus 1. Again, it's just incrementing your old Y value by 1, and then keeping that as your new updated Y value. And this is known as, again, incrementing the variable. Yep. Okay, now let's talk about variables in more detail. So a variable is a name for a location in memory used to store a data value. And we use these variables to save and update values constantly based on the calculations we do, like we just did in the previous examples. And programmers have the ability to store any type of data they want in our memory location, but its type cannot change. If we keep it as an int, we can't just magically change it to a string. So during the program execution, data is saved in memory, and that's why we call it a variable. It can change. So it's easier to update values with variables. And you declare a variable based on the type. So based on that type, you can tell how much memory you need to put aside to hold the data of that type. And upon declaration, where you just have the data type and the variable name, that's when you can really store it in memory. And originally, that value will be null because there's nothing there. Variables declared here and in C++ are not just references. They are names of the locations in memory. Okay. Data types. So there are 3 different overarching terms for the data types you'll see. We have primitive data types, derived data types, and abstract or user-defined data types. So primitive data types, they are the built-in data types to declare those variables, and they're not made by the user. So we have integers there, we have doubles there, we have characters there, we have float, we have bool. And we also have derived data types, which are derived from these primitive data types, which we'll talk more in depth later. For 2 and 3, you can just sort of understand what they are, but we'll go more in depth actually next week and next to next week. So the coming weeks, we'll go over all of this. And then derived data types, they talk about functions, they're arrays. It can even be based on references. And abstract or user-defined data types are the ones that are defined by the user itself, like you're defining a class or a data structure. So it can be classes, enumerations, data structures. We'll talk more about that some more, but the main one we want you to figure out right now are primitive data types. We saw ints, we saw doubles, but we'll talk more about it right now. So ints, they store integer values like 10, 15, 20. They cannot be decimals, and they're very small in memory. Chars are used to store a single character. And there's a difference between chars and strings. So strings use 2 quotation marks on both sides, while char only uses 1 quotation mark. And then doubles, they have decimals there. They take up a lot of space. And bool just has logical values like true or false. So these are the more common ones we want you to focus on since they're a bit easier. And then next week, we'll also go over more string examples, but it's important to just get more familiarized with these easier ones before you talk about float and string. So hopefully this makes sense. And if you have any questions, please keep on typing in the chat. Feel free to email us, and we're here to help. Okay, so let's check out some of these examples on REPL. So we'll have some errors here and there, but that's the main part about programming. It's all about problem solving. So we'll go over what we just talked about. So, okay. I will pose a scenario to everyone and we'll just go step by step. Let's just say I just finished a test and I want to calculate my overall grade based on that one test. So we already know the standard is 90 or above. You have an A. 80 to 90, you probably have a B. Oops. You have a B, and then '70 to 80, you have a C, and so on and so forth. We'll keep on doing this until we get to D and eventually F. So after we do this, we want to print out our overall grade. And the way we're going to do this is just use a variety of different if statements, probably just to test out what is our final grade score. So we'll use some of the data types we just learned about. We'll have an int that is my cumulative test score. But just for our, just to make it easier for everyone, we'll just call this test total, or I'll just call it score total. I guess the hard part about programming is always trying to figure out what the best way to name your variables is. If it's too long, there's a lot of room for error, for misspelling it. So it's always good to just be mindful of that. So we just declared a variable called score total of int data type, and we know that this can take a integer, but it cannot take any decimals. So we're not sure if this is the best thing to do since we are doing some calculations, but let's see, we might not even need to change it to a double. Let's just see. Okay, and let's also have a car to have our overall grade, our final grade, be calculated. So car grade, we can either do direct assignments that look something like this. So car final grade is A. And same thing for our any double we do, we can do double X is 123.6. You can always assign values as you declare them in memory. So you don't have to do this where you have double Y is, or double Y exists and then Y is 9. You don't have to do that. You can simply combine them all up to have double Y is 9. And there'd be nothing wrong with that at all. So we have car final grade is A. And that's how it would look when you are assigning a car to a value. But for now, we don't know what our final grade will be, so I'll just simply declare it. So we have if our test score, which has to be taken in from our user input. So right now I'll just use pseudocode, which isn't really real code. It's just planning, pseudo code. This is for planning. Okay, so if I have a score greater than 90, then I should print out, or actually I wouldn't have to print anything out. I would just assign my final grade to be A. I just want to show an error that I just made here on purpose. Obviously this is pseudocode, but let's try to format it into just better code, almost like C++. So let's just say score total is greater than 90. And I'm pretty sure 90 also constitutes as an A, so we can set it greater than equal to 90. So there's multiple different tests we can do. We can test for equality. We can test if it's greater than equal to something. We can test if something is less than equal to something. Or we can just do the standard greater or less than. So these are all the different comparisons you can make. And there's actually a ton more that we'll do, But for now, just fully understand this and you should be good to go there. And since we are dealing with the car, remember I said it can't be a double quote. That's the main error I was talking about. So you always want it to be a single quote. So we have score total is greater than 90, then your final grade is A. But remember, you always need to have brackets there and good spacing. That's always the best part about programming, making sure your code is clean, works efficiently. Need to test for all of these things when you're coming up with your solution. Now, there's one major problem here. I think we understand how the if statements are going to go on similar to this, but how do we find out our score total? Right now, our score total is technically null because we didn't assign it any value. So let's just take our score from the user input. So what I'll do is I'll just have a CN. Now, this is just a test for you guys. Is it going to be CN this way or a CN this way for score total? Without looking at the error, feel free to think this out and see which one do you think would be the answer. And if this is wrong, what is something we can do to replace it if we were trying to use CN? So if we are trying to use CN, we can obviously change this. So it's like that. The operator itself was wrong. But remember, C out is like this. It uses this operator. So be careful of those errors. I know they come a lot when you're very new to this. So yep, just be mindful of that. So right now we are taking in the score. And we have this if statement that says if our score total is greater than or equal to 90, the final grade is A. That's working good for now. I'm going to routinely check it before I continue with multiple different if statements just to see if everything works up until now. I'll just say 90. Okay. Well, how do I know if it worked? Well, I can simply do some debugging or just trying to figure out if my final grade actually outputted correctly. So rather than outputting it here, I can output it outside the if statements, which is something we're eventually going to have to do for all of them. After we get all the if statements, we need that one line there in the end that'll actually print out our final grade, because ultimately we want to know what my overall grade is. So let's just say I had a 90. Okay, I got an A. That's perfect. But that's just one scenario. So we have to do a ton more scenarios. Let's go ahead and try it out. Oof. Else. Okay. I can do an else if there's just two main options that are just going to come. If it's greater than or equal to 90, or just an else for the other options. And this else will mainly take in when it is less than 90, because this checks for greater than or equal to, and everything else is just less than 90. So that's what it'll really do. So if it's not that, then it just executes whatever is in here. But that's not going to be the best thing to do, since we have so many different statements we need to test out. One is obviously for B, but there's another one for C, and if you get a D or if you get an F in that test. So let's just change this to else if. That is the best possible thing for us to do. So now let's check. So we already, and the reason why we checked higher up is so I won't have to deal with, so I'll just talk about it in 1 second. So over here we have if score total is greater than or equal to 90, it checks for this. So you know that everything else is less than 90. So you know all other statements are less than 90. If this is checking for if it's greater than or equal to 90, if it goes in the next else if statements, you know that all of these statements are less than 90. So basically this is checking if your score total is greater than or equal to 90 but also if it's less or greater than equal to 80, but also less than 90. It's checking for two things here. This is more implicit. It's not really shown directly to you, but that's what the program is doing. It's structured in a way where it's testing two things, actually. Well, it's mainly testing one thing, but since we are in this else if statement, we know that it's not greater than 90. So we know it has to be between this range. So if it is greater than equal to 80, we will just change this to be a B. And for beginners, I suggest not doing what I'm doing right now, which is just copying and pasting. That is something that can really get you in trouble. Like if you don't change this to, if you don't change these values and accidentally put C, D here without changing these, that can also lead to errors. So be careful, especially since you're starting out in the beginning. Try not to copy paste. I know it seems a bit weird since I'm copying and pasting it, but I strongly recommend if you're just starting out, try not to do that since you will lead in errors and you don't want to lead with that. So right now we checked if this score total was greater than equal to 80. So you know that everything else is less than 80. If we are in this predicament, if we are in these two else if statements, you know that it is not greater than 80. So we can just change this to be 70 to 80. And then this could be 60 to 70. So that is the main range of what we're working with right here. And you can end with an else if, but just because you've covered everything else and there's only one thing left, which is the probability of your final grade being an F, then I'm just going to just use an else. That's it. No else if. So let's go ahead and see what my final grade will be. And if any errors do come up, it's our job to fix them. Okay, so let's go ahead and add a 75. So a 75 should be a C. Okay, perfect. Let's go ahead and add a 30. That should definitely be an F. Let's try it. 30. Perfect. So this is our final piece of code right here for this demo. And there isn't anything else over here that we have to cover. But again, just be sure to debug those errors when they do come up. And the main thing we wanted to teach you here is, again, these different if statements and what data types are. And after you have a good core understanding of this, you can move on to other parts. So precise spacing, punctuation, and end Ls, which are basically new lines. Those are all very important in C++. And precision is key. You need to check these border cases. Over here, we could check 70. We need to check that it's equal to. So since we saw that 70 worked earlier, then we know that's perfectly fine. 75 worked, so the middle range works. You need to check so many different things when you are really doing a real life application or software. And in the end, this sums up everything we had planned for week 1. Now, week 2, we'll talk about strings, and we'll go more into that since strings are a complex data type and they have really cool functions and things about them that make them stand out. For this next week or so, just try to remember these data types, and that's pretty much it on our part. Hope this helped and hope you learned a lot, and thank you so much for watching. See ya.